Hello class. In this video, we're going to be looking at different types of multiplication patterns. So we want to look at different expressions that we need to solve and see if there's a pattern that we can use to be able to easily multiply a number. And one of the things is by pulling out base 10 numbers. So that's what we're going to be looking at today and working with today. So before we can get started, pause the video now and write your heading and your assignment title, multiplication patterns, in your notebook. So now that we have that in our notebook, let's look at our first problem. So our first problem here says 400 times 30. I know this is an easy one for you guys to be able to do, but we want to always kind of look at easy ones first when we're learning a new skill, so that we can focus exactly on the skill. So if I look at the number 400, I see right away that I have a base 10 number, the 100, that I can pull out of this. So I'm going to turn around and I'm going to make this, my parentheses of 4 times 100. 4 times 100 in the parentheses does equal 400. So I know I can keep that. Then I cap in my multiplication and I notice that 30, I can do and pull out a 10. So I could do 3 times 10 because 3 times 10 is going to give me 30, sorry. So in parentheses, I'm going to do 3 times 10. Now that I have this, I notice that I can use my commutative and my associative property of multiplication to regroup these. So I can group the 4 and the 3 together while I group the 100 and the 10 together. So I'm going to write them without parentheses, just so that I can really move them, right? Times 3 times 10. Now I'm going to use my commutative property first. And by using that, I'm going to switch the 100 and the 3. So I end up having 4 times 3 times 100 times 10. By doing this, I can easily multiply my numbers. Then I'm going to use my associative property and I'm going to regroup to have 4 times 3 to be done together, and then have my 100 times 10 to be together. By breaking it apart this way, I can easily multiply, right? Because I know 4 times 3, it's a very easy one, that's 12. And 100 times 10, that gives me 1,000. And now it's very easy for me to see that 12 times 1,000 gives me 12,000. So using my multiplication patterns, I noticed I can pull out a base 10 number. Remember, base 10 numbers are any numbers that start with, that has a 1 and then has 0 afterwards. For example, 10, 100, 1,000, 10,000, 100,000. They all start off with a 1 and have zeros afterwards, because they're by our place value system, okay? So again, I look here and I notice I could pull 100 out of 400 and I could pull a 10 out of 30 to be able to help me multiply. I want you to pause this video now and write this example in our notebooks. Now that we have this example in our notebooks, let's try another one. And this is a little bit bigger number, but it's still very simple for us. So let's look at this number, 1,500. When I look at this, I notice there's 2 zeros at the end. So with 2 zeros, I know I can pull 100 because 100 has also 2 zeros. So if I did 1,500 divided by 100, I know I have 1,500. So I could change this 1,500 to be 15 times 100. And I keep my multiplication. Then I look at my next number, 40. And I know with 40 has another 0. I can make this as 4 tens, right? Because 4 times 10 gives me 40. So I'm going to break that out as 4 times 10. When I have this, I'm then going to rewrite it without parentheses because my laws of multiplication says I can multiply in any order in which I choose and still get the same answer as long as there's no addition, subtraction, or division in there, which in this case there's none. It's solely multiplication. So I'm going to write 15 times 10 and then 15 times 100 and then 4 times 10. By doing this, I can then look and say, where can I regroup? And I notice I could use my commutative property of multiplication and switch these two numbers around so that I have 15 times 4 times 100 times 10. Now I see, I can even regroup these. And my associative property says I can regroup because I'm solely multiplying here. I'm not separated by any other operation. So I can put 15 times 4 in one parenthesis. And then I could put 100 times 10 in the other parentheses. Because remember, whatever is in parentheses, I have to do first. And I'm choosing to do 15 times 4 and 100 times 10 before I multiply them all together. So 15 times 4, and I could use repeated addition or my multiplication skills and standard algorithm or area model, whichever one that you choose to do. And some people will just know that 15 times 4 is 60. So I'm going to put 60, my multiplication. And now I have 100 times 10. And with 100 times 10, I know that that's 1,000. Now here some people may get confused because we do have an extra 0 here. But if we look at it, we know 60 times 1 is 60, plus the 3 zeros will give us 60,000. And that is my final answer. Some people will also rewrite this in exponential form, saying that this is 10 to the second power and this is 10 to the first power. Add them together to get 10 to the third power. So let's make that as a side note. All right, 100 times 10 can be written as 10 to the second power times 10 to the first power, which will then give us 10 to the third power, which gives us 1,000. So this is just a side note that we have on how to get there. Okay, I'm going to put a circle around this. I don't want to put a square because it's not my final answer, but I want to put a circle because that is my side note. I want you to pause this video now and copy down everything that's on this slide. Now that we have this example in our book, let's try one more before we do our homework. So we have this number. Oh my goodness, this is a really, really big number, right? 1,450,000 times 20. And this is really, really difficult because we have a large number here. So here we can use our multiplication pattern to notice I end with 4 zeros. So since I end with 4 zeros, I know I can take 10,000 out of here because 10,000 has those 4 zeros. And I know I have 145 10,000. So I'm going to rewrite that in my parentheses, put 145 times 10,000. And then I look over at the 20 and I realize I have a 10 that I could pull out, making that 2 times 10. I look at those patterns because it makes it easier, right? So I write it because without the parentheses because my laws of, my laws of multiplication tell me that I can turn around and multiply in any order as long as I have no other operations like addition, subtraction, and division. So I'm just writing them without parentheses because the law tells me, hey, you don't have to multiply in those orders. And then I look and I realize that it would be easier for me to multiply the 145 times 2 and then do the 10,000 times 10. So with that, I'm using my commutative property to switch these two numbers around, my commutative property of multiplication. So I have 145 times 2. And I'm choosing to do this first, so I'm going to put that in parentheses. And then, sorry, that parentheses came a little bit too close. So let me just rewrite that. 145 times 2. And then my other thing that I wanted to do after that was multiply the 10,000 by 10. So I have 10,000 times 10. And I'm choosing to multiply them in this order using the associative property. So then I look at this and I go, 145 times 2. Now I could use, again, any method of multiplication that I choose to use, whether it would be the standard algorithm, the area model, repeated addition, or any methods for that. So I know that this is 290 when I use those methods. Then here I have 10,000 times 10, and I know that that equals 100,000. Now I look at this and I go, this is easy for me now to multiply, because 290 times 1 gives me the 290. And then I have to add these 5 zeros. So I go 1, 2, 3, 4, 5. After I add them, I can then put my periods in. 1, 2, 3, comma, 1, 2, 3, comma. So now I know my answer is 29 million. And I'm boxing it off because that's my final answer. All right. So I want you to realize by pulling this out makes it a smaller number. Sometimes we could even break this up even further if we wanted to. So I want you to take a moment, pause this video, and write down this slide. Now that we've copied down this slide, I just want to point one thing out before you go over the homework questions. Note that this number, 290, also has a 0. That's the reason why there's 6 zeros here, because I could pull out another 10 here and make this 1 million. So then it would be 29 times 1 million if that's something that you need to do. Okay? With that being said, here's our homework. I want you to write down the word homework and the instructions, as well as the 2 problems showing all your work underneath each. If you need to pause this video and go back to other examples, you may do so, and you may watch this video as many times as you need to. So make sure that you write all of your work down as well as the question.